What is VO2 max and why is it important? So if we look at the name, V stands for volume, O2 stands for oxygen. VO2 max is the amount of oxygen that your cells can actually uptake and utilize, and it's typically measured in minutes. And now there are a few things that can actually limit your VO2 max. The first is actually the amount of oxygen you can take in through your breath, and this is typically limited by the capacity of your lungs. The second is actually the amount of oxygen you can deliver to each cell. And oxygen is carried inside of your bloodstream, so the limiter here will be your heart's ability to pump blood around your body, and possibly the amount of red blood cells that you actually have. But finally, the other limiter here would actually be the amount of mitochondria inside of your cells. Most of the energy we produce will be through a process called aerobic respiration. And this process occurs inside of the mitochondria. And I could fill up the entire length of this video just talking about aerobic respiration. But what's important is that this process requires oxygen. And the limiter to how much energy we can produce through aerobic respiration is contingent on the function and number of our mitochondria. And the cells will only uptake as much oxygen as they can use for aerobic respiration. So really, the amount of oxygen that our cells uptake will either be limited by the amount of oxygen we can get to the cells or the amount of oxygen that these cells can actually use. Interestingly, not all cells actually have the capacity to go through aerobic respiration. And this is because some of them actually don't have mitochondria. But in the cells that can go through this aerobic respiration process, when we are at rest, almost all of the energy we produce comes through aerobic respiration. This is because we have the ability to make enough energy per unit of time using just aerobic respiration inside of the mitochondria, and we have the ability to get enough oxygen to all these cells. So what happens if we either can't get oxygen to the cells, or we need more energy than the mitochondria can create? This is when we begin to take glucose and go through a process called anaerobic fermentation. And the important thing to remember about this process is we don't produce all that much energy because we don't completely break down glucose. For comparison, using aerobic respiration will produce about 36 molecules of ATP, and this is the actual energy that all of our cells use. But during anaerobic respiration, it's estimated we create about 2. So one issue is that we can't create all that much energy. And the other issue is that when we don't fully break down glucose, we're left with lactate and the production of a lot of acidic molecules. And now typically lactate will associate with hydrogen ions, leave the cell, where it can actually then be used in other cells to go through aerobic respiration. And these are cells like the heart, the brain, and other muscle cells. And now it's not entirely decided whether or not this lactate can directly enter the mitochondria, or if it's first turned into pyruvate, which can then enter the mitochondria and be used for energy. However, when we produce lactate in the cell, typically we just kick it out of the cell, and this lactate can circulate around to other cells and be used for energy. However, we have a limited capacity to actually remove this lactate. And the more of this anaerobic respiration we go through, the more lactate we will produce, and the more will build up inside of the cell. In turn, we will also be producing more of these acidic molecules because the lactate is not associating with them and bringing them out of the cell. This will decrease the pH of the cell. And what's important about this is we have many pH-dependent enzymes. And these are the enzymes responsible for breaking down fuel and turning it into ATP. And they only function above a specific pH. So when the acidity raises, this decreases the pH, which inhibits these enzymes from functioning. So in a sense, this accumulation of acidic molecules will shut down the cell. And this really is what limits our endurance capability. This is why we can't simply just sprint forever. So the reason why VO2 max is so important is because the more oxygen our cells can actually uptake and utilize, the more energy we can create through aerobic respiration, which its time limit is almost infinite. But if we can't deliver as much oxygen, we'll have to rely more on anaerobic respiration, And as I mentioned, there's only a finite amount of time we can do this until the cells either run out of energy or shut down due to acidity, or a mixture of both. So how would you increase the amount of oxygen you can deliver to your muscle cells during exercise? As unpleasant as it may sound to some people, the exercise that seems to improve VO2 max the most is actually the exercise that causes us to produce the most lactate. However, the best rule of thumb is try and stick to an exercise where you can't go any longer than between 3 and 8 minutes, meaning that after 3 to 8 minutes, you can no longer maintain the same intensity. And really, one great way to do this is just a max effort mile run. And what's even better is if you do it in intervals, because there will be some residual lactate inside of the cells when you start the second, third, fourth, and so on interval, meaning the accumulation of lactate will actually be quicker and more pronounced. With that being said, I do have a hypothesis as to why lactate itself is so important. And now I give credit to probably the leading researcher on lactate, whose name is Dr. George Brooks. When studying lactate, he's actually found that lactate almost has a hormonal function, in which lactate can actually increase the transcription of almost 600 different genes. And to try and summarize all 600 of these genes in a few simple words, these genes are for the production of proteins. These genes encode for proteins that have functions such as removing lactate from the cell, making cells better at actually using the lactate, and increasing the number and function of our mitochondria. And now other adaptations to exercise that can increase our VO2 max, which is simply just the amount of blood the heart can pump out every single time that it beats. Another adaptation is actually an increased red blood cell count. And these are the actual blood cells that will take the oxygen to the muscle. We also get increased what's called capillarization. And this is simply just the amount of veins and arteries going into and out of the muscle. And the more arteries we have going in, the more oxygen we can deliver. And the more veins we have coming out, the more lactate and other metabolites we can remove. And finally, doing these high-intensity exercises, like I mentioned earlier, will cause us to get out of breath. And in turn, this can actually help strengthen our lungs and increase our ability to uptake oxygen. So all of these things will help increase our endurance capabilities and really our functioning throughout the entire day. However, some people have the goal of losing fat. How could this aid us in losing fat? So anaerobic respiration can only use glucose as a fuel source. However, aerobic respiration can use glucose and fatty acids, which means the more aerobic respiration we can go through, the more potential we have to use fatty acids as a fuel. And the biggest storage of fatty acids are certainly going to be our body fat stores. The best way to think about this is, let's say at baseline, for every 100 calories we burn, 50 of these calories can be derived through aerobic respiration of fat. Well, increasing our VO2 max could allow us to actually derive 60 calories from fat for every 100 calories. So in proportion, we use less glucose and more fatty acids. And once again, the reason why our VO2 max would dictate this is because fatty acids can only go through aerobic respiration. And the more anaerobic respiration we use, the more we will have to rely on glucose. I know this is probably a lot more than you bargained for, but I really enjoy talking about this topic.